So the next data set that I'm trying to work on and do some classification is the garbage classification dataset. Garbage classification dataset. So this one's on Kaggle. So there are various datasets that I've been exploring on Kaggle. So there is one called Taco, right? So the Taco trash dataset. Then there is the garbage dataset. So within this garbage dataset, mm, okay. So I'm basically following this repository. This is somebody who's a researcher in robotics, right? Robotics software and mechanical engineer. And so this is the repo that I'm following. Right, so there are two things over here. One is traffic signs detection and there is trash detection. So this trash detection has got two parts to it. One is trash classification. Uh, the other is trash recognition. So classification is on the garbage dataset and recognition is on the taco dataset, right? Uh, the taco trash annotations in context dataset. Okay, so I'm going to try out both. So YOLO 4 is what I've done earlier. I will get to try out YOLO 5 also over here. So this is what the dataset looks like after it has been extracted uh, from that zip file. So let's see. Okay, yeah. So let's say we want to look at metal. So these are the files. Some of them can be seen here. So lots of different files, different sort of images. So there are a number of different files over here in this, and these are already here. So while I've cloned the repo, so you can see if the class is one, then it is mostly glass, right? Class one is glass, and let's say class three is cardboard. And we might, I don't know, I can't really say, but we might not have a balanced data set over here. I need to check all of this. I have not really seen this. So cnn.py, oh, sorry, classification.py is what we are supposed to run, right? And load arguments. Okay, so function loads the image argument when image added. Okay, so this is if probably that what she's mentioning over here, that if you want to specify a particular image, then you need to run this. Yeah, because args is taking image as the input, so I can say that argparse this one would be the image, but this I'm not trying to do right now. So classification.py. So recommending just to run classification.py. Okay, so does this have a main or anything? Yeah, it does. Okay, so image and model. So, okay, so let's say I skip both these arguments. And I'm running main without an arg. So where is main defined? Okay, data there is this one. Class names. Class names function is defined somewhere. Okay. Classes number and names. Okay. And range length classes. Class names. Okay. So let me just quickly go through this. Then I think I'll start running this code. I need to understand the code first. Okay, so the main is defined in this manner. The data there is there. Okay, it will get the class names. Then this is the seed to obviously replicate the results. Then use CUDA torch. Okay, fine. So if GPU is available, go to GPU. That is okay. Model is ResNet. Num epochs is 100. Criteria is cross entropy loss. Learning rate is very low. Batch size is 32. There is a stop threshold. Where is this being used? Okay. And this is the normalization data for the ResNet uh, for the entire thing. And then maybe there'll be a batch norm or some layer also. ResNet we are using, so obviously there will be something of that sort. Uh, Resize is 32, 32. Then why is the center crop 224? I've just put a question mark over there. I'm not sure. So these are transforms. Okay, those transforms are being composed and two tensor and everything. Okay, this is okay. The transform normalize that mean and standard which we've got over here. This, if I remember correctly, the resonate values. Then dataset split, train validation test. Okay. If not args model, new model. Okay. Model path. And then this is run model. So run model will take this model, which we've already defined up there, which is resonate. Right. Okay, so besides, if we are not choosing resonate and there's already maybe a different earlier model which is there, so then load the state dict from there. Uh, okay, which means load the saved status of the earlier run model, existing model. So that is okay. So this is torch.save and model path. Okay, then this is the test. So that stop threshold is used here. It is also used here. Okay. So test loss and test accuracy will be printed. What about training loss, training and validation? Okay, plot training results, right? So here we'll get that. Okay. And it will show. Save also is there, right? Images accuracy. So, okay. Overwrite the epoch num. Uh-huh. So, um, epoch num is being passed in. So it will write after every 100. Hmm. What if I want to write it earlier? So maybe I can change one this value. Okay, let's see if this works. I put the epoch num save chart value over there, and I just made it equal to epoch num within this function. So okay, so just uh, so I put it at 1 for now, and within run model I obviously don't want to change this because it will run for 100 epochs, and here I will change it. Okay. Uh, so let's see what else. Okay, so no other changes in the code right now. Just trying to run this. Let's see what happens. Uh, Maybe some dependencies won't be there. I've not checked the requirements till now. I'm presuming it will be there. So let's see. Okay. So data garbage classification it can't find. I have not changed the directory structure, and this seems to be here. Maybe I'm not comfortable with the name of this directory. I'll change it. Let's see. So this is what I call silent code. Yeah, till it is not throwing any errors, I have absolutely no idea whether it is running, it is not running, what is happening. Okay, just a relative path issue. So okay, now it's read that and it's downloaded the weights. So resonate 50, uh, but I should have resonate 50 earlier also, right? So maybe I'll check this which one this is. So first it's gone ahead and printed the class names. So where is it? Where is this coming from? The class names. Now I'm just guessing that it has started training. So because I don't see anything else, transform would have happened. Okay, then it has found the data set. Those transforms are done. Um, then I'm sure it's done the data split. Yeah, so it has gone to run model. So the only way I can make out that I will be able to see something is by going here and looking at the uh, results. Besides that, I can hear my mm, Okay, let me try this. Yeah, so I think, but then this is very less usage of the mm, GPU. It has gone to the GPU, that is. Otherwise, yeah, this is running on CPU. Why it is running on CPU? This doesn't seem to be okay. Yeah, so something went to GPU and rest of it was running on CPU. But whatever went to GPU was not using it actively. So maybe some files or something got parked over there. It seems that way to me. I'm not very sure. But I need to look at that code again. I thought it was supposed to run on GPU, right? Okay, I have some prints within this code now. So now I can probably understand what is happening. So it says available device CUDA. So I don't know how much it is utilizing, what it is doing right now. I'm not very clear. So again, I have the same 915 MB over here. And if I look at my CPUs again maxed out. Okay, so that is okay. But coming back to the code. So now it is saying model in train mode. So training is going on, is what I'm presuming. Dataset length is 2527 for the train. Uh, so okay, type train dataset, torch utils data. Okay, dataset subset. Mm, training a new model. Okay, model path. Uh, trash classification code within that model. Okay, model type is CNN resonate. So okay, let's see how long it takes to train and what exactly is happening. Uh, I'm not okay with this. I have no idea what is happening. So this is where the run model is defined in a module called run model. The method itself is called run model. And here it is, run model, import run model. So need to look at this now and understand this before I start running it again. So there seems to be something wrong here because in the train that is defined over here, uh, it says for epoch and range, and then there is this indent which is here. Obviously should not be. So let me check again. Maybe when I maybe I messed it up. I don't know, or maybe there is something wrong in the code itself. I could be seeing this wrong, but there seems to be an issue here. I'm not sure. Any which ways, I'll unindent that and I'll try and run it. Let's see. So I saw somewhere in this code that by default it is running on CPU only. So this is obviously not correct. On CPU, even though I have the CPUs, but it will keep on running forever. This will not work. Yeah, so and the GPU again, that is not okay. It's not even going through one epoch. Yeah, now things are okay. I'm getting similar errors to what I used to get in that official code for the Penfudan dataset, wherein it used to tell me that something is moved on to a torch tensor on the GPU, whereas the other one has not done that, right? So and weight type. So it has got input type as this and weight type as this. So now weights also need to move to device. That is where the issue is, which is okay. So this I'll fix, but at least I'll know that the entire thing is moving to GPU now, right? So this needs to be fixed.